Okay, now we're going to look at how rates change during a reaction and get a little bit more mathematical here and talk about gradients, which I imagine you've done in maths. Some of the terms might be slightly different, so I'll try and be flexible with this. Just make sure you get what's going on. Okay, so this, for example, could be the volume of gas released in a reaction. We saw it earlier, the amount of hydrogen produced, for example, in method 1. Okay, if you're not sure about that, go back and look at it. So, volume of gas and time. It says calculate the rate of this reaction after 40 seconds. So we need the gradient after 40 seconds, which is there. So we take this line, we try and draw this line, and then we've got a right angle triangle, and we can work out the gradient at that point. You'll have done this, I'm sure. The rate would be the rise, that's that, over the run, which is that, which in this case, now you can double check here, but look, 10, 20, that's 20. So each of these squares is 4, okay? 20 divided by 5 is 4. So I've written that down as 132 minus 48 as the rise. And then this is easier, 70 minus 10 as the run, which is 1.4 centimeters cubed per second. Check my working because I might have made a mistake. Okay, and that would be the gradient at that point. We could also work out the average reaction rate for the whole reaction. So the whole reaction up to 80 seconds, they haven't put the 80 in, up to 80 seconds. How much gas was produced? 120 centimeter cubed. So do the maths there. The average should work out to be 1.5 centimeter cubed per second. Check that. Make sure you saw where I got that from. Okay. So that's it. That's a specific reaction rate at a point during the reaction. This is something I kind of mentioned before. As the reaction slows down, one of the reagents or reactants is being used up, the limiting reagent or reactant. So what happens is the reaction rate will decrease until it's finally 0. So the gradient will go to 0. Okay. At the beginning, it's the steepest, and at the end, it will tend to 0. And that's really the maths involved. That's all you need. There's a video here for calculating these kind of rates, which I suggest that you spend a few minutes watching, and then do the questions, read the pages, and do the questions indicated below. Okay, and that's probably enough for today's class. I'm going to put up a question or two online for you to practice these skills. Okay, have a great day, Year 10. Stay positive.